Hey, welcome to a continuation on 5.6. In this video, we're going to be talking about something called oblique asymptotes. It's when the function doesn't have a horizontal asymptote, but it has sort of approaches the slope of a line, something that looks like this for large x. And always, we get oblique asymptotes when the power on top, or I guess instead of power, let's actually just call it what it is. The degree of the top is bigger than the degree of the bottom. And so in this case, we can jump through all the hoops to figure out most of our graph. And I think this would be a good time for you to practice graphing. So I'll quickly sketch it out, but take a second to pause the video and try to draw the graph. All right, so some of the details of this graph, we have a vertical asymptote at -2. We have a root at 0. And our graph, let's see, it's going to look something like this. So what I'm interested in talking about today, though, is the oblique asymptote. That is, this graph, when you zoom out, looks like it becomes almost straight and approaches the line y equals x. So let's talk about why that happens. The first thing is it's going to bring back our old friend polynomial division. We're going to try and rewrite this function. And so when we rewrite our function after polynomial division, we'll see that it doesn't follow just a horizontal line. It's going to follow a line that has a positive slope. And so if we do some polynomial division, just x plus 2 into x squared, and we'll write plus 0x plus 0. First, we're going to match x, and so we get x squared plus 2x. We subtract, and we get negative 2x. We match again, this time with negative 2. We get negative 2x minus 4. We subtract, and we get 4. So then we can actually rewrite our function as f of x equals x minus 2 plus 4 over. So taking our remainder, 4, and dividing it, still leaving that divided by x plus 2. And so now I'll lasso select this and move this computation to the side. So what's going on with this f of x is that now we're seeing as we plug in large values of x, this term is just about 0 for large x. And maybe to clarify, when we talk about large x, really what we're meaning, and I think hopefully everyone's like picked up on this, is that we're looking at x that are just much bigger than the roots. So that's what we're talking about with end behavior. We're just plugging in large x. So if all the roots are between like -10 and 10, then a large x could be anything like 20 or bigger. If the roots are going out to 1,000,000 or 1,000,000,000, then large x might not be until, say, 1,000,000,000,000. Usually large x is just anything considerably bigger than the largest root or the most negative root. Yeah, so for large x, this function is the 4 divided by x plus 2 is about 0. But this part isn't 0. It's still acting like x minus 2. So it's saying our function is acting like x minus 2 plus something that's just a teensy bit bigger than 0. So when we draw our graph out, I'm going to erase this pinkish line before that I drew. There'll be some remnants of it. Oh well. We're going to get that our graph looks like this. And it's going down here. And we have our line. That's terrible. We'll have just a vertical asymptote going through. That should be getting really close to it. And here we see that it's intersecting at -2. And so this is the line x minus 2. Of course, this part on the left is just very poorly drawn. As you can see from my troubles of graphing it, if it was better, it would look a lot more like x minus 2. So this is what's known as an oblique asymptote, where it's not horizontal and it's not vertical. All right, let's take a second to look in Desmos and get an idea of what is going on there, because I think that picture will be a little more illuminating. All right, I'm going to stop my share and then reshare with Chrome. All right, so we'll have f of x equals x minus 2. So there's x minus 2. And then we'll graph the function we were working with, which is x squared divided by x plus 2. All right. So on here, we can already see the vertical asymptote, and we can see our horizontal asymptote, but it's not a clear picture. But as we zoom out even further, we can see we're getting this behavior. We're approaching negative infinity and positive infinity. In fact, let's even put in our vertical asymptote that x equals -2. We can see pretty clearly that we're approaching it. And then for these large values of x, our two functions, the f of x and the g of x, look almost identical. But as we zoom in, we see that they're a little bit different. And as we pick a point far out, we can zoom in. Eventually we see there's, oh, look, there's a tiny bit of space between them. But the grid lines are showing that the difference is really less than 0.1. And if we scroll down even further, we have to zoom in much further to see any noticeable difference. So over here, the difference is on the scale of about 0.05. All right. I hope this helped illuminate some things about oblique asymptotes and also inspired some new questions. I think I'll do one more video with graphing rational functions. And then in class, we'll spend a lot of time working on graphing rational functions. All right, farewell.